All right, we're going to get to one problem here today.
The only problem?
Yep, the only problem that we're going to go
You
to.
look generous.
Huh?
You look generous? Or frustrated?
First period?
First period was a little rough.
Yeah.
This quarter was a little bad.
So fun. We had to throw down on first period.
It was bad. It was a little rough. We had a little bit. Needless to say, we had a nice stare. We had the first period.
You might have been staring. I don't stare. I move on to the next. I don't worry about it too much. All righty. We have a raft with a length of 3 meters, width of 1.5 meters, thickness of 0.12 meters, and a density of 750 kilograms per meter cubed is placed in water. How far below the water's surface does the bottom of the raft sink? Density water, we said is 1,000. I mean, it's close enough. Depends on the purity of the water. Are we talking about lake water, pool water? Or are we talking about swamp water, salt water? We'll use 997 here. So what we have is we have a raft. Oh, dark sauce. Missed out on that one. We have a raft that's put into the water. And when the rafts go into water, it will partially sink into the water. So we have it will sink into the water a dimension of x. It does not fully submerge in water. It doesn't go in water like if you would throw a rock in water or a more dense object that would sink to the bottom. But it would partially submerge in the water. Won't sit on top. Partially it will go down. Well, what we have here, we have, once again, in the y direction, we have our force of gravity, and we have our buoyant force. The force of gravity, once again, is mass times gravity, mass of the object times gravity. But the buoyant force, how we calculate the buoyant force is density of the fluid times gravity times the volume of the object. But if you remember back, that's the volume of the object that's submerged. Because when objects go down underneath the water level rises. Okay? The weight of that water level rise is also equal to your buoyant force. So the only thing that's making the water level rise is the amount that is submerged in this raft. So this raft, here's your water level. Here's your water level here, here. Is this portion of the raft is what is submerged, and that is the volume of the object that you have to deal with. Once again, it's the volume of the object. The buoyant force is the volume of the object. You deal with the volume of the object, or the volume of the object that is submerged. Okay? So you deal with whatever is underneath the water, gives you the buoyant force going upwards. Well, if we first deal with the force of gravity, it's mass of the object times gravity. Well, what we are given, we have a length of 3 meters, a width of 1.5 meters, and a total depth from here to here of 0.12 meters. We're given the volume of or the density of the object is 750 kilograms per meter cubed. So knowing the volume of this, or the density of this object, and being able to calculate the volume of the object, we can then find the mass of this object. So I'm going to write a total volume of the object. Well, how can we calculate the total volume of this object? It is a rectangular prison. Length times width times height. So we have our 3 meters, we have our 1.5 meters, and then we have our 0.12 meters. So the total volume of this object comes down to what, Justin?
0.54.
0.54 meters cubed. Good with that? Yes, no, maybe so. All right, so once we find the volume of this object, we know the density of this object. Our mass of the object is our density of the object times the volume of the object. 750 times 0.54. The meter cubed will cancel out. So what do we get for the mass of this object, Jacob?
1388.9.
1388.9.
Oh wait, times.
We'll find 750 times.
I divided with it. 405.
So what did you get for the mass of the object?
I got 405.
405. Is that better? All righty. So we can find our force of gravity is equal to 405 times 9.81. So the force of gravity, which is once again our weight, what is the weight of this object, Seth?
2,973.05.
2,900?
3,000.
3,000. 975?
73.
Is there any change in that?
0.05.
So that is the pull of this object with the force of gravity. Our buoyant force is once again density of the fluid times gravity times the volume of the object that is submerged. Well, density of the fluid, we can use 997. We have gravity, which is our 9.81. But what is the volume of the object that is submerged? Well, how do we find the volume of the object? Which is length times width times height. But what can we use as our height here? Because not the entire thing is being submerged. Well, we can introduce a variable into our equation. Variable, this is the equation. Equation, this is the variable. As the amount submerged. X. You have X amount submerged. So my volume of the object submerged, I can still do length and width, but my height is just now X. So my volume of the object submerged is equal to our length still of 3 times our height, or width, which is 1.5. But we don't know how far the height is underneath the water. We don't know that. That's what we're trying to find. So I can multiply 3 times 1.5 to give me 4.5x. So our buoyant force is 997 times the 9.81 times the 4.5x. If we multiply these out, what do we come down to, Matthew?
We got 44,012.6.
44,000 what? 44,012.6. X? Yes, no, maybe so. We go with that number. But we have to make sure we include the X in there. That's still times X. So, let's take a look at the physics, the dynamics of what's going on here. We throw this raft in the water and it partially submerges. But then it stays there. Yeah, it may drift a little bit left and right, but it stays there. By chance, did anybody see, there's a video out there. Japan had a very big earthquake, or Taiwan had a big earthquake. This is past week. There was a video of a guy that was in a swimming pool when the earthquake occurred. And the water was swooshing all over the place. This guy is trying to walk out with the water swooshing all over the place. It's sort of cool. Anyways. So this raft is just sitting there. Is the raft sinking anymore? No. Is the raft jumping out of the water? No. So what is true about my force of gravity and the buoyant force? Is there a net force? No. If you take the sum of your forces in the y direction to give you a force net, since the object's not jumping out of the water anymore, since the object's not sinking anymore, this has to equal a value of 0. Not going up, not going down. So we have our force of gravity, our buoyant force, first, 44,012.6x, plus our force of gravity, which is a negative, since it's going downwards, 397, or 3,973.05. And when I add these up, they should add up to 0, because I have equilibrium. I have the object's not jumping out, and the object's not, here we go, got some sunshine, we're playing today. the field down there at high level drain a little bit better. Or they'll bring in the helicopter. So we can add this to the other side, divide by our value here. What is the amount that sinks down? Evelyn, what do you get? 0.09 meters. So it's 0.12 up, and 0.09 will come down and submerge in the water. So you have a little bit, 0.03 still above the water. Okay. Once again, the key thing to remember is when dealing with the buoyant force, it is how much is being submerged. If the whole thing's being submerged, that's the volume of the object. But if there's only a partial amount being submerged, then the buoyant force is going to be a little bit different. If you float on your back in water, you're laying in the pool and you're just floating on your back, you're looking up and doing the day, checking out the birdies up there, okay? Part of your body is submerged. Only part of your body is submerged, not your whole body is submerged. Okay, so if your whole body is not submerged, you still have a buoyant force there. That buoyant force is how much of your body is being submerged. That gives you your buoyant force. Questions you have? As promised, just going to do one problem today. We'll call it a day. Sorry if I disappoint you.